Okay, so now the agenda for today's session is we are going to start the introduction about big data. I think so you have already aware about something about big data. We are going to discuss about what is big data and what is Hadoop and what are all the differences between your Hadoop framework versus your currently used tools, RDBMS tools. And we are going to discuss about this architectural perspective of Hadoop, overview of Hadoop architecture. Okay, Hadoop
Okay.
architecture in sense we are going to discuss about its infrastructure architecture, that's master slave architecture, and we are going to discuss about its database architecture, that's distributed database architecture, and we are going to end up with the Hadoop ecosystem components. What are all the associated components coming under Hadoop ecosystems? And what are all those functionalities of those components? And finally, we end up with what are all the various job verticals associated with this Hadoop. Okay, this is the agenda for today's session. Today's session has been planned for around 1 hour 20 minutes to 1 hour 30 minutes. Okay, this is the time schedule for today's session. Let me start with our session will be little bit interactive one. Also because being we people are new, I need to aware to which extent that you are aware of what are all information that need to be delivered to you, so that if and only if I know the level of expertise currently in possession by you in this technology, I can proceed accordingly. So we will have some question based interaction. You no need to worry about that. Okay, let me first start with what is big data. Any idea on big data, Kameswar?
No, simple knowledge like
Google?
kind of a new technology.
Okay.
That's all.
To work with multiple, big data, large number of data counts.
Yeah, very good. Okay, large number of data count. So here the data count alone is not going to be play a role in deciding whether it is a big data or it's a normal data. Apart from that, there are several other characteristics through which we can associate the big data. That thing is going to be discussed now. Okay. So and another thing is that
Okay.
if you have any doubt in the due course of our discussion, you please don't hesitate in clarifying your doubts. So I will always welcome in clarifying your doubts. Without clarifying your doubts, you no need to proceed further. Okay. Whatever may be the doubt, whatever maybe it may be actually no issue. I will try to make it with some other examples so that I can make you easily understandable. Doubt, if you have doubt and if you without asking doubt if you proceed means the later sessions which is a continuation of the previous session, you will feel difficult and this doubt will be propagated until the end and it will make a big impact in making you knowledgeable. So you please, I request you all, at any point of time if you have doubt, don't hesitate in clarifying. Okay, this is my humble request. Okay, now first we start with that of what is big data. Big data is nothing but is used to represent today's digital data. Today's digital data has been termed as big data. What is digital data? What are all the sources of the digital data? Today, everything has been computerized. We are living in an automated industry. We are living in a machinery industry. So starting from a grocery shop, end up with huge shopping malls, weather forecasting, scientific, military, banking, insurance, portfolio management, share, everywhere. Whatever applications that we are going for, healthcare, everywhere it is digitized. Everywhere we need to dependent upon these computers. The amount of data that is generated and the type of data and the rate at which the data has been generated is of very huge in volume, which is not at all supported in today's RDBMS. You are aware of RDBMS, which is used for data storage and processing. Okay, relational database management tool. Here the architecture of RDBMS is a client server architecture, you all aware. You have data stored on a machine called as server, and here in this server you have a data, and this is a centralized database architecture. That means you have data stored on only on a single machine only, and how a user can interact. The user can have an interaction to the data stored through an interface called as a client computer. Then the tool that used for having interaction has been termed as a front-end tool, and the database where we have in our server has been termed as backend. These are all the terminologies that you are aware of. Okay, here the RDBMS softwares like Oracle, MySQL, SQL Server, etc., etc. Hundreds of softwares are there, using which we store and process the data as of our today's traditional way of storage and processing. Okay, RDBMS is having some limitations. So in terms of volume of data that it can store, in terms of the variety of data that it can process, in terms of the rate at which the data is coming inside. So in several factors, we have a lot of drawbacks associated with it, the RDBMS software. So being today everywhere is computerized, everywhere is machinized. You want to take care of data in terms of minimum terabyte, petabyte, zettabyte, and so on, whatever may be the applications. Here, being your RDBMS is a centralized database storage. That is, your data can be accommodated on only on a single server. Okay, you can't able to extend the data beyond that. So you can't store data across multiple servers. That is not possible in this RDBMS technology. What is the maximum available capacity of the single server? To that extent only you can able to accommodate data. Let me assume you have a hard disk of 2 terabyte, and at the maximum you can have 4 hard disk in this normal architecture of this client server centralized. Then at the maximum we can able to store only 8 TB of data. But if you take any applications today, that we take application Facebook per day it is almost generating 500 terabytes of data. If you take social networking sites like Twitter per day it is generating almost 200 terabytes of tweets. Whether it is a weather forecasting, if you want to predict the temperature of Chennai or Bangalore, you want to handle not less than 10 TB of data per day. Here you need to crawl data across these various temperature sensors located across hundreds of data source destinations in Chennai. You want to crawl data 24 hours a day, and based upon that information you need to decide the minimum and maximum temperature, like weather forecasting. What are maybe, for example, if you have a aircraft travel from Madurai to Chennai, a flying duration of 1 hour, aircraft is generating around 20 terabytes of data. Okay, so whatever may be the applications, if you go for a medical health care, so Apollo groups of hospital in Chennai, they are generating around 5 terabytes of data per month at the average. Okay, so the patient's histories in terms of scan reports, in terms of medical reports, in terms of prescriptions, okay, everywhere it is generating around terabytes and petabytes of data, which is not at all possible to be accommodated in today's traditional database storage architecture, RDBMS. That's the major drawback associated with this RDBMS. Okay, so the data which is consisting of the above said features has been termed as big data. I will let you know with more clarity. So these are all the data sources. The data sources may be man-made data sources, or the data sources can be a machine-made data sources. Such as you want to capture this RFID, you want to get this sensor data like the. In terms of man-made data sources, it may be transaction records, which may be server logs. Okay, so almost all sort of data which is generated by man or machine need to be stored and need to be processed. Okay, so the tool that we already have, our RDBMS, does not possess the capacity to accommodate this huge volume of data for storage and processing. Therefore, we go for a new concept called as the Hadoop, which is a tool which replaces this RDBMS. Now, we are going to start our discussion with this introduction. We are going to now start the discussion of what is big data. Okay, big data, how you can define a big data? You can define in the following: any data. Here, any data here refers to, it may be a structured data, it may be a semi-structured data, or it may be unstructured data, which is beyond two things: the storage and processing capability of today's traditional RDBMS data. The architecture followed by this today's traditional RDBMS. The architecture followed by RDBMS is, one is the centralized database architecture, and the second in terms of infra is client server architecture. So centralized database in sense you can able to store data only on a single machine. Okay, you call this machine as a database server in which you can store the data. The data can be accommodated to the maximum allowed permissible level of your storage capacity of this server. Okay, so if the server is, as of our previous example, if the server contains 4 hard disks, each hard disk with 2 terabyte of storage, at the maximum you can able to store 8 TB of data. If you want to store 10 TB of data, that is not at all possible here. In this case, what you need to go for, you need to go for a concept called as a storage box. Either you need to go for a NAS box or you need to go for a SAN box. You might have heard about this NAS or SAN. If not, I will let you know how it will look like. So EMC, Hitachi, NetApps, they are all famous corporates. EMC SAN storage, like EMC, Symmetrix, Clarion. These are all storage boxes. Okay, you can find now. Each box is you contain multiple hard disks. These are all hard disks. Okay, if these are all the hard disks, here what you can do is you can store the data here, and your application may be running in your server. This may be your computer server in which your application may be running. You have data stored here in this. We call this as a storage box. Some of the famous companies are EMC Square, NetApps, Hitachi. You might have heard about this. Each hard disk assumed to be is of 2 terabyte. Imagine you have 10 hard disk in a row. We can go and add this row. In this particular example itself, we have around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15 hard disk in a row. Into 3 rows, we have 45 hard disks. Each hard disk is of 2 TB instance. You can have a storage of around 100 TB in this storage box. Okay, this box is called as a sandbox or a NAS box. Here you have data stored here. Your application may be running on a server. If the application is in need of data, data will be read from this storage box and it will be bring to the server where your application is running. That is the way by which you can store data in a box and you can fetch the data whenever it is needed. So this architecture is well suited if you want to store and process data in terms of gigabytes. Okay, imagine your normal film whose size is around 3 to 4 GB of size, a normal film. Okay, let me make a current film, a Tamil film which is running around 2.5 hours, will occupy 3 to 4 gigabytes of storage. If you want to copy this film into a pen drive, how much of time that you need? Minimum you need around 3 minutes. Imagine if you have a data of 100 TB. If you want to bring the data, else you just look, if you have a data of 1 TB which is stored in your box, if you want to bring the data into the server for even around 3 GB of data, it took around 3 minutes. So if it is 1 TB means for 3000 GB of data, it took how many minutes? So 3000 minutes. 3000 divided by 60, 6 it took around 50 hours for transferring. This is a 3 TB of data in this speed. If it is 1 TB, it need around roughly 10 to 15 hours of time duration to move the data from this data box into the server. This is a time consuming process if you take into consideration transfer a huge volume of data. As of that we have discussed, if you go for big data, the volume of data is of very high in volume, beyond terabytes. Therefore, the solution of having your data in a storage box like EMC, NAS or Sandbox and bringing into the data into the server whenever it is needed is not the best suited because of the transfer of huge volume of data will took a lot of time for its transfer. That is not at all recommended here in this architecture. Therefore, we need to go for a separate architecture called big data. Okay, I will let you know now. Okay, sorry for disruptions. Okay, so this is not at all a best solution, having your data and moving the data here. Okay, so we go for the another concept called as Hadoop to accommodate our requirement. Okay, so the small definition which let you know what is the drawback associated with storing the data in this centralized database architecture or storing the data in a separate storage box and moving the data as of your requirement. This activity is applicable if it is RDBMS. Why so? Because we need to handle the data in terms of gigabytes. Okay, 1 to 10 gigabytes of data. It took a minimum time for its transfer. Whereas big data is one, it starts with minimum terabytes, petabyte, and zettabyte, which is not at all recommended. Moving data from a storage box into this database server itself will be a time consuming process. Okay, so this architecture of centralized database storage is not well suited if you go for what we call as big data. Okay, that is the limitation associated with. So that is, it is termed any data beyond the storage and processing capability of this RDBMS and possessing the following four key characteristics. Okay, the characteristics.
Raman, one doubt.
Yes.
Sorry. Actually, big data is not a database, correct? Big data is a
Generic
concept
term. It is
which,
a generic
which is
term.
generic term. Okay.
Yeah.
So generally, the huge volume of data, we call it as big data,
No,
correct?
and I am going to discuss this. Wait for 5 minutes and you put up your question.
Okay. Okay.
Okay, so here any data here refers to, it may be a structured data, it may be a semi-structured data, or it may be unstructured data. What is a structured data? The data that we are currently handling in your RDBMS, which is in forms of rows and column format. That we take a employee table with the employee number, a employee name, a job, a salary field. You have employee number 1, employee name Ram, job DBA, salary 9,000. Employee number 2, employee name Arun, job engineer, salary 9,500. Okay, here this data can be accessible by specifying a row comma column interaction. If I want to access this particular DBA, means this is first row and third column. So the way by which the data is organized in form of rows and columns. This is an example of structured data. What is an example of semi-structured data? Your documents, your PDF, your email, your XML files. They have a structure, but the structure is not a fully defined. The structure is partially defined. Okay, this is called as a semi-structured data. Your SMS, your Twitter tweets. These are all examples of semi-structured data. Then what is unstructured? Audio file, video file, images, okay, cartoon pictures. They are all examples of unstructured data. Okay, so these are all various types of data which is coming under. If you take into consideration today's digital information, around 80% of today's data is coming under a semi-structured and unstructured. Only 20% of data is coming under a structured data category. Okay, the key characteristics associated with big data is first one, volume, the second one is velocity, the third one is variety, and fourth one is veracity. Now we can have another values, so on, so on. Okay, these are all the four key characteristics. So now come back to the discussion. Any data refers to, it may be the following type of data, which is beyond the storage and processing capability of this centralized database architecture, which is nothing but the architecture followed by RDBMS, and possessing the following four key characteristics: volume, velocity, variety, and veracity, has been termed as big data. So the data volume, minimum it need to store terabytes, petabytes. The volume refers to the amount of data that you need to store and process. The velocity refers to the rate at which the data has been generated. The speed of generation of data, that is, if you have a server, database server, if a number of users are putting a request to this data, the amount of data that is coming inside has been termed as velocity. And third one, variety, that now we just discussed in terms of variety has been concerned. We have structured, semi-structured and unstructured data. The big data is one which comes under all the three categories. And fourth one, veracity, is reliability of your data. How far your data is reliable. If you make a comparison with respect to these following four characteristics with RDBMS and big data, you may aware of the difference between RDBMS and what is big data. Also, this is a general definition. Okay, why you can't able to store and process data in this RDBMS architecture? The reason is being it is a centralized database. You can store data only on the single server. You can't able to extend the data beyond this server. Now for this, your Oracle is following a concept today called as Oracle Golden Gate. If you are working with Oracle, you may aware Golden Gate is a third-party technology in integration with RDBMS like Oracle. It supports now distributed data storage and processing. It is one of the most demanding thing in today's RDBMS industry has been concerned. Okay, Golden Gate. So this is the current technology evolved around 1 year back. Okay, the reason behind why you can't able to accommodate this huge volume is because of its centralized database architecture. You can't able to extend data beyond that. Also, in terms of the above four characteristics, if you take into consideration velocity, variety, and veracity, you may have a clear clarity. Let me have a difference between your RDBMS and what we call as big data. First characteristics, let me take the volume of data. Here RDBMS support gigabyte and up to 1 or 2 terabytes of data instance. You can use this RDBMS. RDBMS works fine. Whereas big data is one, it starts from minimum terabyte, petabyte, zettabyte, etc. For example, as of initially discussed, Facebook one day alone it is generating 500 terabytes. If we take at the average of 1 hour, it is 25 terabytes of data per hour. So this is the volume. RDBMS support, if you have the database size within 1 or 2 TB, then it works fine. But in terms if it beyond 1020 TB, you can't able to use the RDBMS because of its centralized architecture. Then the second thing, velocity, the rate at which the data has been generated has been termed as velocity. So here if the data generation speed is gigabyte per hour, your RDBMS works fine. Whereas if you take this Facebook, what is the rate of generation of at average? It is generating terabytes of data, more 25 terabytes of data per day. But if the data, you imagine this is your server, Flipkart server. Let me make it as a Flipkart server. Flipkart is announcing a 3-day sale with around 50 to 70% of discount on its item. Under normal circumstances, at an average per second, the number of users visiting, let me make the Flipkart is 1 lakh. Plus Flipkart, if they are announcing a sale, the number of visitors may be 10-20 lakhs. Okay, if because of its lot of discount offered by Flipkart. So if the number of users request that is approaching the Flipkart server, if it is a gigabytes of request, then you can have your RDBMS. But under these circumstances, it won't be gigabytes. Your number of requests approaching will be terabyte and petabyte of request. And if you have your RDBMS server to tackle this request, your server will get crashed. That is the second difference, velocity. If the data is generated gigabytes per hour, your RDBMS works fine. If the data is generated beyond that, if it is terabyte per hour, your RDBMS server will get crashed. Here, this is the major characteristics associated with big data. The data generation speed will be terabyte per hour. And third characteristics, variety. Your RDBMS support only structured data. It does not have a support to semi-structured. Here, your big data is one, it is structured data, semi-structured data, and unstructured data. All the three comes under big data. That is the third important difference. Fourth difference, veracity refers to how far your data is reliable. So imagine if you have a table employee, and if you have this employee number declared as an integer, if you try to insert 1, it will permit. If you try to insert A1, it won't permit. Why so? Because A1 is considered as a varchar data type, whereas your employee number is supposed to receive input only on integer. Because of this violation, it won't allow the data to get into. Similarly, if you have your employee number declared as a primary key, then if you try to enter a null value, or if you skip entering the value, it won't permit. Here the concept is that the data need to be pre-processed. You need to clean the data. You should enter only a clean data. You can't able to enter any dirty data here. So if you enter dirty data which is violating the schema, or which is having some issues like missing values, irrelevant values, or data inconsistency, it won't be permitted to enter into. The data need to be of very clear. Data need to be cleaned. Then only it will allow. Whereas if you take big data, you can't able to ensure this clear data. Also because the data sources that is coming from, which is a server log, which is a data from sensors, which may be from RFID. Those data will not have a well defined pre-processed clear value. It may suffer from several anomalies. We may have some inconsistency, we may have missing value, we may have irrelevant values. So those data need to be accommodated here in our data storage and processing framework. So here a big data is one which does not have assurance of always it is a clear data, which may have some anomalies. Your framework, your tool which is used for storing and processing big data should have some inherent capability to tackle these anomalies. That is the fourth characteristics associated. Veracity refers to how reliable your data is. Okay, these are all the four major characteristics based upon you can differentiate what is big data and what is RDBMS. RDBMS, the tool used for RDBMS is Oracle MySQL. Similarly, the tool used for big data is Hadoop. RDBMS is a generic term. Similarly, a big data is a generic term, which is used to represent a data with a huge volume and generating with a very high velocity and possessing the following different variety and in terms of veracity. All the four characteristics togetherly will have an influence in designing whether a data is a big data or a normal data. Now you put across your question. What is your restart? Now, these are all the four major differentiation which differentiates your RDBMS data and big data. Another important thing is architecture, database architecture. In terms of this architecture has been concerned, the RDBMS follows a centralized database architecture. A centralized database architecture.
Raman, can you show how physically Hadoop looks like?
Definitely.
Yeah.
Once the today's session has been over, you will know how a Hadoop cluster will look like. I will also let you know with this already configured Hadoop. No issue.
Okay, thanks.
My session will be around 70% practical, 30% concept.
Okay.
RDBMS, you come across big data, and more specifically, let me make it use the difference between these tools, Hadoop versus RDBMS tools like Oracle. It is a centralized database architecture. That means you have data stored on only on a server only. And the architecture here, the client is used for user interaction. Simply, the client acts as an interface through which the user will submit a query. The query will be taken to the server. The user will submit a query here. The query will be taken to the server where you have your data. The query will be processed and the result will be returned back to the user. Okay. The data storage and data processing both takes place only on the server. The client machine simply acts as an interface through which the user can have interaction with the data stored in the server. So this is the architecture of this architecture. The database architecture is centralized client server architecture. Whereas the architecture followed by the big data tool Hadoop is master slave master slave distributed database architecture. What is distributed database? What is master slave? Here, the big data, if you want to store data, being the amount of data is very huge, you can't able to store data on a single server. Therefore, what you do, you will have multiple servers to store the data. Okay, you have data stored across multiple servers. Imagine the server where you store data here in Hadoop has been termed as data nodes. We are going to discuss about this architecture. Hadoop is a master slave architecture. Hadoop we call it as a cluster architecture. Okay, cluster means a group of computers. A group of computers, each and every computer will serve for some purpose. It's called as a cluster. The architecture followed by Hadoop is master slave. Some computer has been designated as masters, some computer has been designated as slaves. Example, you have in your master a computer called as name node. You have secondary name node. You have a computer called as a job tracker. Similarly for slave, you have data nodes and you have task tracker. This is the architecture with respect to Hadoop 1.x, version 1.x. In version 2.x, we may have a different architecture. Okay, so here in version 2.x, version 1.x is suffering from some problems. Therefore, to overcome this problem, we have added some new features. Again, the architecture is a master slave. Here we have once again we have a name node and we have a standby name node, not a secondary name node. We have a standby name node and you have a resource manager. You please make a note of all those things. Resource manager. You have application manager. You have a scheduler. These are all the components, daemons associated under master. And under slave, once again you have data nodes. You need to configure a computer called as a node manager. You have a application master. You have a container. These are all the components associated with Hadoop 2.x version. Okay, so once our discussion on 1.x has been completed, then what are all the problems associated with 1.x and how you can resolve the problem using Hadoop 2.x will be understandable to you. Okay, yes, you just make a note of this architecture. You have some computer to be considered as a master computer, such as a name node is a separate computer, a secondary name node is a separate computer, job tracker is a separate computer, and you have a data node as a separate multiple. You have the data nodes. On top of the data node, you have task tracker. Task tracker is a daemon. This is the architecture followed by the Hadoop master slave architecture. Okay, so here you have the following: a computer called as name node.
Raman,
Yes.
Hadoop is also having a third version, right? 3.5 or 3.7 something.
Now it has evolved. Now
Oh,
only around 1 to 0.5 to 1% may use 3. Out of 100
oh.
implementation, nearly 60 plus is running with 1.x and more than 35 plus is running with 2.x. It is a
So currently in this, you do the second version, I mean 2.0.
beta version. It is a beta version yet to fully implement. 3.
Oh,
Okay. These are all data nodes. Data node 1, data node 2, up to you have n data nodes. On top of the data nodes, you have a task tracker 1, task tracker 2, up to n task trackers. So this is the architecture of your Hadoop. Okay. This is we call cluster, which is nothing but a group of computers, and the computer on the top are designated as master computers. A computer on the bottom has been designated as slave computers. Each and every computer will do some functions. Okay, the name node's functionality is to take care of managing the entire cluster. It is a responsibility of the name node to take care of managing the entire cluster. Okay, the secondary name node. Whenever a name node fails Under the circumstances, the secondary name node will help the name node in recovering from its failure. We have a separate discussion on these particular nodes. In today's discussion, I am going to view overall what is the name node and what is secondary name node. A job tracker node's responsibility to execute a job. To run a program, it is a responsibility of the job tracker in running the program, managing the program. Here, the data storage and data processing, the storage of data and processing of data, both takes place only on the slave.
Means already it's a predefined.
Which one?
A job tracker. It's already predefined program, right? Job tracker.
It is not a program. It is a server, a separate computer under which you need to configure this particular service, job tracker.
Oh.
These are all computers. Imagine these are all computers. You want to separate, configure these separate computers in your Hadoop cluster. Okay, so here, how many name node? You need to have it one name node, one secondary name node, and one job track. You can't have more than this, one name node or one job track. It is mandatory that the name node and job tracker need to be one, and secondary name node may be one or more. Most probably in 99%, one secondary name node is sufficient enough. And the number of data nodes here are n in numbers, n number of data nodes. Here n depends upon two factors. One is the volume of data that you need to store. The second factor is the hard disk size of your data nodes. Example, you have 10 TB of data to be stored. This is your volume. And you have a data node with a storage capacity of 2 TB. How the data has been stored? So 10 TB of data, you have a data node with storage capacity of 2 TB means your 10 TB of data has been divided into a 2 TB chunk each, and each 2 TB will be stored across the data nodes. Therefore, how many data nodes that you will be needed? You will be need of 5 data nodes. With each data node capacity is 2 TB. Into 5, you can able to accommodate 10 TB of data. So the number of data nodes depends upon these two factors. Okay, the volume of data, here the volume of data in this example is 10 TB. The hard disk capacity of the data node, if it is 2 TB. So if the volume of data is 100 TB and hard disk capacity is 2 TB, you need 50 data nodes. If the hard disk capacity is 4 TB, you need 25 data nodes. So these are all the two factors which let us influence to decide how many number of data nodes that we need to have in our Hadoop cluster. Okay. So here the responsibility of the Hadoop administrator in terms of this is the architecture that you need to establish. Yes.
The same way RDBMS also looks like a data node in some kind of way.
Under which circumstances you store data in your client in RDBMS?
Oh, it's okay. It's a client server.
It is a
Only
client
one server will be available.
here you have only server. In RDBMS, the analogy here is it is a server, it is a client. You won't have data stored in client. The client will simply act as an interface. Whereas here it is reversed. You have your data stored only on the client computer. That is your slave computer. Data processing also takes place in the slave computer only. Okay. Under the supervision of masters. The master won't do any data processing and the master does not store any data, but it will control the process of storing and processing under the client machine. Once our discussion progresses, you may have an idea of what is the role of master and what is the role of slave. Yes, this is the architecture of Hadoop. Okay, who developed Hadoop? Hadoop is a open source developed by Apache Open Source Foundation. What is by using which language? It is developed using a Java 6 programming language. What is the architecture? The architecture is distributed database architecture and the infra architecture is master slave. So here how you can here the hardwares associated with this Hadoop cluster, you can make use of a commodity hardware. Commodity means low cost hardware. All the software associated are open source softwares. These are all some of the key characteristics associated with Hadoop. Now Hadoop being is open source, you can download and you can add some modifications and you can release under your own name. This is your Apache Hadoop, which is open source. By downloading this Hadoop and adding some new features to facilitate easy user interaction, several distributions has been made. Out of this, the prominently used is Cloudera Hadoop, and you have Hortonworks, and you have MapR, and you have EMR, Elastic MapReduce. Like there are 100, we call these as a distributions, Hadoop distributions. So imagine a Linux. Linux is a open source. Okay, from Linux you can download the software and you can add some new features on top of it without violating the overall architecture. And you have this Red Hat Linux, you have this Ubuntu, you have this CentOS, you have this Debian. These are all called Linux distributions. All these will have 90% in common, and only difference is 10%. Each and every company may have its own interface which facilitates easy user interaction, and some 4 additional functionalities have been added on top of it. We call this as a Linux distribution. Similarly, we have an open source Hadoop, which was managed by the Apache Open Source Foundation. And what happened here is, here these corporates, Cloudera, Hortonworks, MapR, EMR, like there are hundreds and hundreds of distributions are there. We have IBM distributions, Big Insights. We have Oracle distributions like everywhere. So here they take the open source software and they add some new features. For example, Cloudera added a feature called the Cloudera Manager. Hortonworks added a feature called Hortonworks U, through which the user interaction will be made more simplified. And also the management and monitoring will be automated there. So in case if you want a support, you can get a support if you have this Cloudera Hortonworks distributions. Whereas if you does not need a support and if you are not willing to pay anything, you can straight away go into Apache Hadoop. Okay, so these are all the various.
Cloudera and Horton,
Yes?
so Cloudera and Horton was giving support only, not.
They are old distributions. Okay, they have some new features. They downloaded the Apache original software and they added some new features on top of it and they release under the own name. They are called
So
distributors.
there are separate certifications, right? So what is the difference between a Cloudera and Horton?
What is the difference between Oracle and SQL Server?
Okay.
What is the difference between Red Hat Linux and CentOS? Similarly, okay.
Okay.
In industry, if you take CentOS or Red Hat occupies the more market share because of some unique features. Similarly, if you take any cloud, any Hadoop distribution, Cloudera leads the market. Also because which may have some more easy and more easy configurable interfaces. You may have some new features on top of it. That's the reason. That's a 80 to 90%. All the thing will have same feature. Cloudera, Hortonworks, MapR, that it differs only by its 10-15% of new features and the support that they are providing. Based upon that technical support, people may choose Cloudera or Hortonworks. Out of 100, nearly 50-55% are using Cloudera and 30-35% of persons are using Hortonworks, and remaining distributions will occupy that. Okay. Our curriculum deals with Cloudera and Hortonworks for administrator. Am I making sense with this presentation? Do you have any clarity? Please let me know.
Okay.
Yes? Shall I proceed further? Okay.
Yeah.
So now what we have discussed so far, we have started up with our discussion on what is big data and what is Hadoop and what is the solution, what is the architecture, everything. Now, you have from this came to conclusion that RDBMS is not suited. Also because of its centralized database architecture. And we use currently Hadoop, a framework which support a distributed database architecture. How the data has been stored? If we have 10 TB of data in a RDBMS, these 10 TB of data need to be stored on a single server if the server is having a capability. If not, you can't able to store 10 TB of data. Here what happens? You have a computer called as a data node under which the data has been stored. How the data has been stored? This 10 TB of data has been split into a chunks of 2 TB, 2 TB each, and each 2 TB is stored on the data nodes. You have now in this case, assume you have 5 data nodes and the hard disk capacity of the data node is assumed to be 2 TB, 2 TB each. Therefore, to accommodate this 10 TB of data, you need 5 data nodes in this case. If you want to store 20 TB of data, how many data nodes that you need? For storing 20 TB of data, you need 10 data nodes. Okay, data node 1 to data node 10. So you can go and you no need to worry about. If you want to store again 30 TB of data, you can extend this cluster with additional 5 data nodes. Now you have 15 data nodes. So you no need to worry about the amount of data that you need to store. As ever, whenever the data size increases, you can go and add your additional data nodes. This process of adding these data nodes as of when it is needed has been termed as horizontal scalable. This is one of the important concepts associated. The advantage of this horizontal scalability is you no need to worry about how much of volume of data that you need to store. You can go on and add your data nodes whenever it is needed. Please make a note. So this is the architecture currently followed by Hadoop for storing data under this distributed database architecture. Here the if Hadoop is the only tool, no. We have an intermediate tool called as data appliances. We have another tool called as data appliances. You might have heard about this Teradata. You might have heard about this Exadata. You might have heard about this Green Plum, Netisa. Have you heard about this Netisa? I think so. It is by IBM. EMC's Green Plum. So Exadata, Teradata, I think so it is of Oracle Corporation. Okay, what these data appliances? It is nothing but a sophisticated hardware with this customized software. These are all higher end servers which is designed more specifically for storing what we call as big data, and those servers will have some softwares accommodated to handle those big data. They are called data appliances. If you go and make a Google, you may aware how a data appliances will look like. If we make it a Teradata appliances. Teradata appliance for they are all higher end servers. Okay, the servers will have high capacity. Let's look into this. The server 670 model can store 12 TB of data. This server can store 186 petabyte of data. Okay, so they are all higher end servers which has been designed for this purpose alone. Data storage, data processing, everything will be taken care by the server. Okay, so Teradata, we have captured any kind of data. Any kind of data means it may be a structured, semi-structured, unstructured data. Okay, it case web clicks or Twitter data, voice data. Okay, we have discussed about all these things. Data storage and data processing can be accommodated here because of its sophisticated hardware and customized software. So we have a solution in form of data appliances which we couldn't make it using our RDBMS. Then what is the drawback of these data appliances? The drawback associated with the data appliances is if you want to procure the server, you need to invest in terms of crores. The hardware cost and software cost is very, very high. Imagine you need a fully populated data appliances will come around 5 crores. A company, a startup company or a entry level company, okay, small corporates, for them it is almost not affordable to invest up to 5 crores to 10 crores for its infrastructure alone. If you take a country like India, developing country like India, if you took 100 companies, nearly 70-75% of companies are coming under startup or mid-level companies. Only around 20-25% of companies are coming under enterprise companies like Wipro, TCS, Reliance, etc., etc. So for those companies which is occupying around 70-75%, getting a solution in form of data appliances is not at all affordable. Also because of huge cost of investment for establishing the infrastructure, and all the associated softwares are all not open source. They need to pay for which extent that they are storing the data. So these are all the drawbacks associated with the data appliances. But almost all companies now have the data which we designated as big data, and they need a solution for storing and processing, which is not at all affordable in form of data appliances. Here comes a messiah from the open source community called as Hadoop. The Hadoop is a framework developed by Apache Corporation, which have an architecture of a distributed database and with a master slave architecture, using which you can store and you can process data in a low cost computer with very high processing efficiency. Almost all the softwares that you are going to make use of it for data storage, for data processing, for data crawling, and for databases, everything are all open source softwares. Here the hardware associated with this Hadoop is called commodity hardware. Okay, we call this hardware as a commodity hardware. Commodity means low cost hardware. You can even use your i3, i5 or i7 computer for your data nodes. Okay, you no need to go for a sophisticated higher end server as that of your data appliances. You no need to go for a server which need 5 to 10 crores, okay, for your infrastructure. What you can do, if you go up with a computer like i3 or i5, imagine you need around 20-25,000 for this. So let me make a case. If you want to have this 5 data nodes, assume it is a i5 computer with 2 TB hard disk, which comes around 25,000. If it is 5 computer into 5, you can make it with 1,25,000. You can able to form a cluster. So if you want to store 20 TB of data, then you need 10 data nodes. In this case, it is around only 2.5 lakhs. So such a simple way, using a low cost hardware, you can able to establish this Hadoop cluster. So this is the way by which yeah, data which is not possible to store and process in RDBMS can be stored in data appliances, but the drawback is you need to invest huge cost for establishing the infrastructure, and also the softwares are all not open source. You need to pay for that, and to overcome from this, we have a new framework called as Hadoop, developed by Apache Open Source Foundation, which is distributed, and the hardware associated with this Hadoop are very less cost. You can make use of a commodity hardware and all the softwares associated with this are open source software. Okay, by the way, with the minimum investment and with no almost no cost for software, you can make use of this Hadoop cluster for storing and processing what we call as big data. Is it clear? If you have any
In Hadoop, right?
here too, we have a failure. That failure will be taken care. I will let you know how. Okay, here you have a master, you have a name node, you have a secondary name node, you have a job tracker, and you may have multiple data nodes. Data node 1, data node 2, up to n data nodes. Here your data is replicated. Assume B1, B2, here too you have B1, here you have B1, B3, B2, B3. Like your data will be replicated. Yes, B21. Okay, so here if a data node fails, no need to worry about. you have data replicated across multiple data nodes. What happens if this master fails? Since you have only one name node, only one secondary name node, only one job tracker. If the master node fails, entire thing in the cluster will be down. Why so? Because the master alone will maintain the metadata information about the cluster. What is metadata? The data about the entire cluster. This is a Hadoop cluster which compromises of the following master nodes, name node, secondary name node, job tracker, and with the above set data nodes. So all the information, how many files are there, how many blocks are there, who is the owner of the file, what are all the access permissions, those information has been termed as metadata. Those metadata information has been managed by the name node. And if a name node fails, nobody knows what to do with the cluster. Even though other nodes are working, you can't do any activity. You can't able to perform a read or write. You can't able to run a program in your cluster if a name node fails. Similarly, if a job tracker fails, you can't able to execute any job. Therefore, because of its importance, here you can't have a commodity hardware here. It is an entry question. You can have a commodity hardware for your data nodes. Since the data node is having a replica of the data block across multiple nodes, a single node failure won't have an impact. Whereas if this master node fails, being you can have only one master, only one name node. If a name node fails, even though all your data nodes and job tracker or secondary nodes are working fine, you can't do any activity in your cluster. Therefore, it is not recommended to go for a commodity hardware for your master. For that, you need a higher end servers. In terms of hardware, you need a higher end servers which will withstand from a single point of failure. Okay, you need have a little bit higher end server for your masters, and your data nodes, slave nodes can be configured with a commodity hardware. Why so? Because of the following reason. Yes.
Okay.
Okay.
Right. Name node is the one which decides from which DN, I mean, data node the data has to be picked. Correct?
Yes, yes. The name node is the controller of the entire cluster in terms of data storage. The job tracker is the
Okay.
controller of entire cluster in terms of executing a particular job.
Okay. Okay. Then what is the activity of the secondary name node?
If a name node fails, then it will help the name node in recovering from its failure. We have a separate
Okay.
discussion for name node, secondary name node, separate. It took around 2 hours of discussion. Being today's session
Okay.
is planned for 1.5 hours, I want to let you know a bird's view of what is Hadoop. We have a separate
Okay. Okay.
session for this discussion. No issue.
Okay.
Now you
Thanks.
are aware what is master and what are all the roles of a master and what is the hardware that you need to accommodate for your master and what are all slaves, what sort of activity a slave will do, why you can go for a commodity hardware, how in case of failure, how you can ensure high availability. Yes?
So secondary name node server also requires a high-end server, or
Definitely,
it
definitely.
requires only number of
All
users.
the master need to have a higher end server.
Okay.
All the slave can be accommodated on a commodity. By default, in a real-time environment, you have master configured with Intel Xeon server with 8 or 16 cores, 16 core processor, minimum of 128 or 256 GB of RAM memory, and with a hard disk capacity of 4 to 8 TB. That's all. Whereas your slave nodes, again, it is a Intel Xeon a 2 or 4 core processor, or you can have a i7. Okay, the number of processor will be less, 2 or 4 core, and you have a minimum of 32 GB of RAM in a real-time environment. 32 GB of RAM, and you may have a hard disk of around 4 TB in each and every node. These are all the normal hardware associated with your hard master and slaves. Okay, so now we are going to discuss about this Hadoop ecosystem components. Hadoop ecosystems. So Hadoop is not a single entity. Okay, so we have several components here. For data storage, we have a component called as HDFS, Hadoop Distributed File System. Here, which is nothing but your data nodes. Okay, all the hard disk of your data nodes togetherly form a HDFS. Okay, we will have a discussion laterly. Just make a note in data nodes. And you have data from different data sources for data crawling, for data ingestion. We call this data ingestion or data fetching. We make use of a tool called as Scoop, Flume, now Kafka. These are all data crawling tools. And for data processing, we make use of a tool called as Hive and Pig. And for databases, we can go for a HBase or we can go for a MongoDB. There are several etc. And we have a scheduler called as Uzi, the job to make the job automatic scheduling. We have a coordinator called as Zookeeper. We have a tool called Ambari for easy guide-based user interface. Guide-based management tool. We have Ambari, Zookeeper, Uzi, HBase, Mongo, Hive and Pig. We have different frameworks like Spark. You have a framework like Spark. You have a Uzi for scheduler, job scheduling. You have a guide management tool called Ambari. Apache Spark is a framework which replaces a MapReduce. So Hadoop consists of lot of these ecosystems. Okay, each and every ecosystem will do some functions. Okay, we will have a discussion of those ecosystems in a later stage. For example, you have the data sources. These are all data sources. The data sources may be a RDBMS source. It may be from a data warehouse. Which may be from social networking sites like Facebook, Twitter. It may be from a web server logs, a server log. It may be a flat file, anything. All this data need to be fetched by the following tools. We can make use of a Scoop. We can make use of a Flume. We can make use of a Kafka. And the data will be placed in your Hadoop cluster. In your Hadoop cluster. And to store and process data, we have tools like Hive. We have tools like Pig. And you can have a database like HBase. Or you can have a database like MongoDB. And everything can be coordinated using a tool called as Zookeeper to take the coordination service, to coordinate all the things. You can also have a tool like Uzi. So this is the architecture. This is the architecture. So these are all each, and similarly there are hundreds of tools are there, hundreds of ecosystem tools in which each and every tool is meant for a particular purpose. So these are all the tools that is commonly used. Okay, Hive, Pig, Zookeeper, Uzi, Scoop, Flume, Kafka, and the database like Mongo, Cassandra. Okay, in almost all distributions, all the tool will present 85% of tools will be present, a common tool. And some distribution will have some additional tools. So this is the way by which your Hadoop ecosystem will facilitates to do certain activity for data crawling, data processing and data storage. So I will let you know with some additional examples in the forthcoming sessions. Now it is time to wind up today's session because I got an assignment on 1:15 for another batch. Before winding up today's session, it is a questionnaire session.